Thank you. I feel the warmth from that welcome, and I embrace that warmth. Yeah, as Julia said, my name's Dave, nearForm, and what I'd like to do is I'd like to tell you a story. But I'm going to have to break the presentation. Oh, hold on. Forgot to put my notes up. All right, cool. So this is a talk about performance told in a series of stories. I'm going to have to come clean. I may have gotten a little bit carried away with the whole story idea. I think I've been influenced by this community too long with the meta vibes and the poetry of Emily Rose. I really got my head into this whole thing with meta literature and stuff. So there's a lot of really clumsy attempts to use narrative techniques throughout the talk, more as a way to amuse myself as I did the talk. But to employ a MacGuffin, some techniques that I won't be using are the predestination paradox, because that requires a time machine. Anyone got one of those? The quibble, because I'm not a lawyer, and the unreliable narrator, because I never lie. I never lie. On that note, I'm also absolutely avoiding allegory, amplification, asyndeton's, alliteration, and assonance. Thank you. I'm glad it wasn't just me who found that funny. Okay, flashback. January 2016. This is the frame story, the overarching narrative. Matteo and I, we have a mission. We had a mandate. And that's to help people with performance problems and simplify the optimization process wherever we go. A little bit of prose to set the scene. It was a golden crisp morning in Italy. The smell of rich coffee lingered pleasantly in the air as I made my way along the marbled porticos of Bologna's ancient palaces towards Matteo's apartment. That's the only time I'm going to do that, don't worry. It's not all like that. It is all like that. As we settled down to the business of preparation, Matteo told me a story about his recent work with News Corp for the Times. I'd like to play that, but I don't think it's going to play, so I'm just going to have to do an impression. Sorry, Matteo. The network card became the bottleneck. It's poor impression, poor impression. You say it, Matteo. Shout it. Basically, Matteo had worked on a real-time publishing system where the network card on an AWS machine became the bottleneck. The code was faster than the network card. So with that in mind, I pondered upon this incredible story. And I looked through the code that was responsible for this. And an angel jumped on my shoulder. And he said, "This is amazing. But to the untrained eye, this code looks exactly like a novice wrote it." And then a devil jumped on my other shoulder and he said, "Who cares? It's fast, isn't it? It's what they wanted, what they needed, high performance." And I realized that they were both right. What we needed wasn't a moral dilemma. What we needed was a moral solution. And the moral of this particular sub-story is to comment optimized code, because otherwise people might try and come and fix it for you because it looks really amateurish. There is this weird correlation between code that looks really amateurish and really high-performance code. But, side note, comment at the top of the function, outside of the function, instead of inside the function, because that can actually cause a de-optimization. Yeah. Okay. But as much as I was enjoying the contemplation, much like this talk, a sense of urgency had crept in. We had a lot to prepare and little time. The purpose of our gathering was to codify our performance knowledge into training material and a consultancy workflow so that we could deliver it to a client the next week. And that client was Net-a-Porter. Net-a-Porter are a fashion brand based out of London, pretty much entirely online. They have Net-a-Porter and Mr. Porter brands. There's a case study. You can get these links, these slides on my GitHub, and there's a case study link down at the bottom there. They rang us and they wanted the kind of help that empowers them to make changes instead of relying on us to come in again and again and again. And that's the kind of help we like to give at nearForm. So we had 2 days showing techniques and tools, and we had 2 days applying techniques with each of the teams to their code. It was multiple code bases. After we left, and they implemented the changes, they were running 1/3 of the servers, that's 1/3 of the cost as well, 2 times throughput and half the latency. So they had double what they had before with 1/3 of the cost. So Matteo and I, we came away from Net-a-Porter inspired. We now had a good idea of the things that our community actually really needs when it comes to profiling performance. So time for a metaphor and some pretty serious hyperbole. After this engagement, we had our own Cambrian explosion. All right, I thought that was funnier. These are the big 3 things that we created as a result of this, but there's a bunch of other stuff like Autopsy, which is a postmortem tool, fast-safe Stringify, which will stringify things fast, quick format, Fastify, which is like an alternative to Restify that's super fast, also Steed, but that predates it, which is basically async but with less overhead. But the big 3 were Pino, 0x, and Autocannon. Anyone, show of hands, heard of any of those? Great, cool. Probably from us. But we're not the only ones talking about them anymore. Thomas Watson's going to do a talk in Moscow about them. Okay, so let me tell you some stories about these big 3. Deus ex machina is like a pretty glib technique used in plots, where you basically, at the end of some impossible position that you've gotten the characters into, you say, but it was all a dream, or you say aliens turned up and saved the day, or you just have some crazy thing. But it basically means the God from the machine, and it basically means the impossible becoming possible. And we had a moment like that with 0x. And it's all about flame graphs. Anyone know what a flame graph is? Okay, that's a pretty high percentage. Must be speaking to the right crowd. Basically, for those who don't know, it's a visualization, really nice visualization of the amalgamated call stacks from a sampling period. So say you sample 1 millisecond and you capture off the CPU, and you capture what stacks are on the CPU, and then we turn them into this graph. And the hot points on the graph represent time that a function was seen at the top of the stack for that millisecond slice. If you see that a lot of times, it's going to get redder because it's probably blocking the event loop. The other thing to look out for in flame graphs is where you have a wide top, because that means there's a function that's called very late on that seems to be taking up a lot of time. And you can also see the kind of complexity that you're dealing with. If you have a flame graph with lots of stacks and lots of towers or like what look like skyscrapers, very thin skyscrapers, it's probably quite complex. But if you see something very flat, then you're doing well. So most of the guys that we were training were on OS X. And flame graphs on OS X up until this point were basically impossible. They had been possible, but Apple had done 2 releases since then and basically crippled dtrace, which is what we use to capture the stacks. But in Node 0.12, which was the highest at that time, it's amazing how far we've come since January, they introduced Perf basic prof. And part of what this does is it puts a mapping file in the temp folder that maps hex addresses to the JavaScript symbol names. So we wrote perfsim really quickly the day before going in and working with these guys that basically takes the hex addresses and maps them to the JavaScript symbols and allows it to work inside the flame graph. We were still taking about 6 or 7 steps to create a flame graph at the time, but at least we got it working on OS X. After the engagement, I went ahead and created 0x, which takes the time that the amount of steps that it takes to create a flame graph and put into basically reduces them down to 1. So it takes just 1 command now and you can get a flame graph. On OS X, Mac OS, Linux, and coming soon, thanks to Matteo, Windows, which is just crazy. It's crazy hard to do on Windows, and we actually have some really great guys from Microsoft helping us, Aaron Robinson and Brian Tolson. Okay, so 0x, the name 0x, because we were staring at hex addresses so much, basically. They all start with 0x, so that was just in my brain, and it was free. Next story, Autocannon origins, fighting the red herrings. So Autocannon basically means machine gun in cannon form. Has anyone heard of Apache Bench? Yeah, WRK? Okay, so basically it's an HTTP benchmarking tool like those things, but it's written in Node, not C. And even at that, it's able to put your server under 10% more load. Saturate it 10% more than what these other tools can do. It's now being used in Node Core for performance testing, mainly because it works on Windows really easily and AB and WRK don't. One of the secrets to Autocannon, again, this is Matteo's work here, one of the secrets of Autocannon is that it uses net instead of HTTP to build the requests. It also uses something called pipelining, which no processors support, and something called HDR histogram, which allows us to record the entries, the measured times, in less than 5 nanoseconds per record. So we take that overhead off. It's scriptable. Again, the others aren't. And that allows some really interesting stuff. On one of the projects after this, we were able to quickly start automating workflow by scripting particular scenarios in Autocannon. So one of the reasons you might want to do that is sometimes you need to test multiple routes at once if they're calling the same function to see the interactions between those routes. Like if you have a polymorphic function and you're calling that function with different inputs, it's going to cause deops on that function, which you're not going to expose unless you're testing multiple routes at the same time. I should mention that this is basically just a summary of all the things that happened to me in 2016, all the good things in Perf stuff that happened to me in 2016. We have a booth, the nearForm booth. If you want more depth, you want to know more, just come talk to us, all about flame graphs, whatever it is, we'll be there, me and Matteo. Wave, Matteo. There you go. The other thing about scriptability is it can be used as part of a CI pipeline. And there are people now doing this. If you do that, you want to work with percentiles, not averages, so that you can figure out where your minimum sort of performance regression would be. Okay, and now on to the big boy. Science and magic, the birth of Pino. So Pino is a high-performance logger. Who's heard of Bunyan? Yeah, Winston? Yeah. So I think those are the people using Bunyan and the people using Winston, basically. Pino is basically compatible with Bunyan. You do 100,000 ops, basic logs of a string with Winston. It's going to take 3.5 seconds. I think 100,000, that's quite a lot. Well, if you have 10 logs in one request and you're doing like 50,000 requests a second, it's actually not that much. You do 100,000 logs with Bunyan, 2.5 seconds. With Pino, 250 milliseconds, and in extreme mode, 100 milliseconds. So we basically built Pino, again, it came out of this Net-a-Porter engagement, where they were like, well, what logger should we use? And we were like, we'll go build one. The whole idea is the less time spent logging, the more time spent processing I/O for the intended case. So you want to serve responses to requests. Let's focus on that instead of focusing on logging, right? Matteo called it Pino because he's Italian and there's a pine tree outside his house. Okay, time for some rapid-fire cliches. Deliver us from eval. Our first iteration of Pino basically used the eval trick. Who knows the eval trick for performance? Anyone? One? Okay. It's simply this. If you have some inputs to a function or some state, and you can serialize it, you can make it a string, like say it's a primitive, or an array that you can JSON stringify or whatever, you can do that and actually create a function as a string, and then eval that function to make it a function. And now it's going to be super fast because it's not accessing any state. So our first iteration, I think it was about 350 milliseconds, something like that. But I had this conversation with Matteo. I was like, even though this is perfectly fine to do because there's no user input involved, people are going to freak out. No one's going to use it. What's the yellow mean? Okay. No one's going to use it. So I said, let's rewrite it and see if we can hit the same time. And that's the first PR. The first PR did that within about 10 milliseconds. So it went from 350 to 360. But in retrospect, if we hadn't have done that, we wouldn't have made all the other optimizations because you're kind of stuck once you do the eval trick. There's more of these on the slides on my GitHub. I had to pull some out because of time constraints. So the second one is the second PR. Basically, when you stringify, it takes a lot of time. And we found with 0x, when we ran it on Pino, that a lot of time was spent in stringifying. So what we did was we just concatenated strings for everything that we knew about and popped the top level values off an object and put those in as strings, or if there were objects, then stringify them. And that actually gave us a 20 to 25% improvement on the benchmarks. So now we're faster than the eval case. Pino's ecosystem has been growing quite a lot. We've got the web framework integration, which we wrote ourselves immediately after we did Pino because we wanted to make sure they were fast. We got Happy Pino, Express Pino Logger, Koa Pino Logger, Restify Pino Logger. We've also got compatibility layers. James over here, who's joined us as a contributor on Pino, he wrote Pino multi-stream to allow for even greater bunion integration. It's not recommended that you keep with that, but it's a good way to migrate across. Pino debug, which I wrote because I missed my plane. I had an extra day of doing nothing, so I wrote Pino debug. You know the debug module? Anyone use the debug module? It's used by a lot of things, it's in Express, it's everywhere. What Pino debug does is it basically takes all the calls to debug and runs them through Pino, and you get a 10x improvement, plus it outputs JSON with the PID and the hostname and stuff like that. So it's a great way to get some good trace info from in production. So that's the Pino story. Okay, finally, behind the veil of whom we speak not. So I have to not talk about the project or the client in this case, but once we'd done all that stuff, we were asked to help out with some performance on a system that dynamically generates an initial payload for the user and also does some mass user real-time system stuff with WebSockets. This was a much bigger engagement, so what we did was we profiled the entire deployment in staging. So we set up a machine that we would basically throw stuff at the deployment from. If you're going to do something like that, don't use AWS T2 instances because they're burst instances. You'll get really unreliable results because they fluctuate depending on supply and demand. The ideal is an M3 medium or M3 large. The temptation is to go for a clustered profiling solution, get a big cluster and hit it, but you can get a really long way with just one AWS M3 medium. So we would throw stuff at it, we would check the load balancer, the machine and container settings, cloud health checks, measure CPU, memory disk usage, check caching layers, and then actually check the node process. If you are going to do something like this, you need to set the machine up with a bunch of different settings so that it will actually allow you to put the throughput through that you need to. Again, these are on the slides. This is a gist by Matteo. Another thing that we did, and come talk to us at the booth about this, I'm running out of time, real-time system profiling and PubSub. We basically wrote a little library called Anger that helps to profile we basically emulate users over WebSockets. Since then, they've actually went on and they automated their reporting system, as I was talking about with Autocannon. They actually are doing this. So I'll finish with an epilogue, a prophetic epilogue. And also I'm going to run the credits while I do it, because that's really important. So here's the scene, a utopian future. Many people have contributed to Pino, 0x, Autocannon, Autopsy, and more. but others have cut their own paths. All have learned the ways of Node Perf. We live in an enlightened age where the tension between elegance and performance is perfectly balanced by adhering to measurement and well-established practices, and there is harmony among the devs. Thank you.